All right, this is part B. Go back a page where we were before. This is part B on page 11. All right? And what's different about this is that the A isn't 1. So when we get to the bottom here and we have it in what's called vertex form, I'm going to go ahead and write this near the bottom of that frame in your packet. We are now going to have a number out here for A. What do you think it'll be? 3. Whatever the dilation is in general form, that's going to be the dilation in vertex form. Okay? So we're going to have a 3 out there. So there's one extra step, and then one step that you have to think about that's a result of factoring out that 3. Here's how it works. So take the 3 and the x squared and separate them with a parenthesis. That's step 1. So you're kind of putting a boundary between the 3 and the x squared. When you do that, you're also hoping that the b, 21, is divisible by 3. It usually will be. Is it? Yes, it is. Because what you're going to do is you're going to take the b, 21, and divide that by 3 because you're factoring out that 3. So what do you get in here? 7x. Real quick, you see if I redistributed this, what would that be? 3x squared. What would this be? 21x. Now the minus 35 on the end, it's kind of scared by everything that's happening over here, so it actually gets out of there. The negative 35 jumps out before you even start factoring things. So it's not part of the, oh, I hope it's divisible by 3. It doesn't care. It's gone. It left. It thought this was a little too complicated, so the minus 35 is there. So that's the first thing you need to consider is you're factoring out that 3 so that we end up with the dilation out front. All right? Here's the next part. This is the result of what we just did. When we decide what the perfect number will be to add and subtract, here's what you need to keep in mind. You're going to create an imbalance here. Let's pretend that the perfect number is 4. That's not correct, right? That doesn't complete the square. The perfect number will be half of 7 squared, which isn't 4, all right? Let's just pretend it is. If it was 4, what would we really be adding here? We would actually be adding 4 times 3, which is 12. So you have to counteract that by subtracting not 4, but 12. Let me show you again with another number. Let's pretend that the missing link was 11. 11 is half of 7 squared. It's not. Pretend. So if you're adding 11 in here to complete the square, what are you actually adding? 33, so you have to subtract 33. When you have the dilation, you got to remember that one thing. The number you subtract is affected by that A value. Got it? So now let's get down to business and let's find the missing link. What is half of 7? 3.5. 3.5 is half of 7. Squared. It is 12.25. There's a little shortcut. If you're sitting in this room right now, we talked about it earlier today. If you're watching the video, you don't know what we're talking about. The shortcut to 3.5 squared is, what's 3 squared? Plus 3 plus 0.5 squared is 0.25. So 12.25 is the missing link. Let's write it in blue. And this is wrong, right? It's so wrong, it's not even going to remain on the board. It's going to disappear. Why don't you subtract 12.25? You need to subtract 3 times that amount. So that would make it 36.75. That's what you need to subtract. Okay? The equation's still balanced. We took away what we added, and we're really close. All right? We're close to the final solution here. Yes, go. Ready to wrap this up here, and we're going to take what we have in this line. I'm going to erase this. This was our little shortcut on how we got the 12 1/4. And we're going to go ahead and finish it up. So it's going to be y equals. The 3 gets copied down. We're going to create the x minus h squared part. We're going to create the perfect square part right in here. Here's how this technique works. You take your x here. You move the squared out here. Whatever this sign is, plus, goes here. Half of 7, we had it on the board a moment ago. 3.5 lands there. Got to figure out what the leftover becomes because that's our k. If you're down 35 and you lose 36.75 more, you're now down 71.75. Okay?